In this lecture, we're going to talk about how to name ketones and aldehydes. Step 1 in how to name organic molecules is to determine the suffix. For ketones, the suffix is -one. For aldehydes, the suffix is -al. Again, when we determine the parent chain must include the ketone or aldehyde. We also need to number the parent chain so that the first or most important substituent has the lowest possible number. Because aldehydes are at the end, by definition, they will always get a number 1, and so you don't actually have to include the number for the aldehyde, and we'll get into that a little bit later. Let's look at some examples of ketones. Here we have 2 examples of pentanone. In this top example, we are numbering to put the ketone on the 2 position. If we numbered from the left, 1, 2, 3, 4, the ketone would be on 4. So we call this pentan-2-one, or you can also say 2-pentanone. 3-pentanone becomes 3-pentanone regardless of whether you number it from the left or from the right. 1, 2, 3. Either way, it gets the same number, so that's an easy one. You can call it pentan-3-one or 3-pentanone. Here's an example of a dione. In this case, we have 2 ketones. Remember that when you have 2 groups, it becomes a di. Also notice that instead of calling this pentan-dione, we have to add the E, so it becomes pentane-dione. You can call this molecule pentane-2,4-dione because the ketones are at 2 and at 4, or you can call it 2,4-pentane-dione. Here's our next example. This is a trione because we have 1, 2, 3 ketones. It's also a cyclohexane. Remember, we have to have that E there because we're using a di or a tri, and the same is true for tetra and so on. We want to make sure that we're numbering to give lowest possible numbers. So we're going 1, 2, 3, 4, because that puts ketones on positions 1, 2, and 4. If we numbered the other way, we'd have ketones on 1, 3, and 4, and we always want lower numbers. So this is cyclohexane 1,2,4-trione, or you could also call it 1, 2, 4 cyclohexane trione. Here are 2 more examples. We have cyclohexanone here. Notice that for cyclohexanone, we don't need that pesky little E because we only have 1 ketone. We also don't need a number because when we're cyclic and we only have 1 ketone, it's assumed that you're putting that ketone at the 1 position. Over here, we also have butane-dione. This is another one where we don't need the number because there's no other way to draw this molecule and have 2 ketones. If you start putting your ketone at position 1 or 4, then it's no longer a ketone, it's an aldehyde. So butane-dione doesn't need numbers to indicate where the ketones are because there's no other place to put them. Now let's look at some examples of aldehydes. We have propanal over here on the left. Notice that we don't need a number because the aldehyde has to be position 1. We also have a pentanal over here at the right. Again, the aldehyde has to be position 1. In this case, we have an ethyl group at 2 and a methyl group at 4. We put this all together, it's 2-ethyl, 4-methyl pentanal. Here's an example of a dial. Again, because we have more than 1 aldehyde, we have to add that E there, just like we did with the diketones and the triketones. It's only possible to have 2 aldehydes and have 1 at each end, so we don't need the numbers again. Here's an example of a cyclic aldehyde. We call this cyclopentane carbaldehyde. This is kind of weird because now the aldehyde is attached to the cyclopentane ring. You don't have to know this one, but it's just kind of an FYI that once you have rings and aldehydes, the naming gets a little weird. Here are a few more examples of aldehydes. Again, the names in parentheses are common names, so you don't have to know those, but they're helpful. For example, formaldehyde over here, its IUPAC name is methanal because there's only one carbon, but formaldehyde is the common name, and that's the one you're probably used to hearing. Also notice that the name changes when we have a benzene attached to the aldehyde. This is benzaldehyde. It's not even that weird carboxaldehyde thing we were doing before. So the take-home message is anything with some sort of ring is going to be named a little bit differently. Again, we have a couple more examples of ketones. An important distinction here is acetone. This is a common reagent you see in the lab, and you'll notice that formally it's called propanone. No number needed because there's only one place to put that ketone, but this is one of those where it's good to know the common name. We also have butanone over here, where you don't need a number. If we number this, you'll notice that it's 1, 2, 3, 4 on the 2 position, but if we put it on the 3 position, then that flips where the 2 is supposed to be, so we still don't need a number for that one. We also have a couple examples here of benzenes with ketones. In this case here, we have a methanone because that's our parent chain, and it has a phenyl group on both sides, so that's why it becomes diphenylmethanone. On the bottom left here, the parent chain is 2 carbons long, so this is an ethanone with a phenyl ring attached to it. We don't need numbers for either that ketone or the benzene ring because there's really only one place to put these. If you move the ketone to this right carbon over here, it becomes an aldehyde, and also if you move the benzene to this right carbon, then that ketone becomes an aldehyde. We also have here butenone. This is starting to get into more than one suffix-changing functional group because we have a ketone and an alkene. And you'll notice that we, again, don't need numbers for that ketone or that alkene because there's really nowhere else to put those functional groups and get that same name. Here's another example of a butanone. Again, we don't need to specify where that ketone is because there's no other place to put it, but we do need to specify the position of the methyl group at 1, 2, 3. And so this becomes 3-methyl butanone.